We've already reached the break, so I'm going to move it over to the panel now. While we wait for further questions, if any one of the attendees want to ask a live question, just again, the reminder, raise your hand and I can promote you. While we wait for that to happen, I'd like to, if all three authors could enable their cameras just so that we can go into the panel. Perfect. Thanks very much. I'd like to ask one question to all three of you. So we have seen three systems today that all optimize for a different kind of storage interface. The Aurora system was promoting a single level store where applications effectively don't have to do anything. The memory is just made persistent by the operating system transparently. The YNFS paper is optimizing for direct memory access to storage in non-volatile memory. And then MicroFS is perhaps optimizing more for the traditional POSIX file system interface. So if I look at that and I kind of come in as a new application developer, which one of these interfaces should I use for my application? What would each of you tell me? Maybe we start with Emil.
So I would say that it really depends on how long you're going to be writing the application for. So if you want to just write it and be done with it, use Aurora. And then if you want to be able to get, if you want to write just a bit of code, also use Aurora. And if you're using disks, how do you explain this? Like I think that Aurora really shines in that, showing that if you have a lot of throughput, you can really simplify you can sacrifice a bit of performance, which is the continuous checkpointing that we do for the application, in order to get minimal work. So I think that if you, it's basically, if the design space is maximum performance, and here you have minimal developer effort, Aurora is around here. And the rest, like even conventional systems, are around here. Mm-hmm. So it is, I'd say if you want it to be completely painless and you don't mind the small overhead, Aurora is your project.
Mm-hmm. Is it just about performance, or is it also about kind of consistency and persistency requirements that my application might have? Just kind of going back to that question that we had earlier started by John Austerhout as to how do applications communicate this. Would I be better off with a different interface than a single level store in those cases? Or is it really truly just about performance?
That is interesting, because so while we do have a single level store, and we essentially what the single level store does and why it is, because we also reintroduced an API if you want a lot of performance. So somebody could ask, what is the difference between that and providing file writes and syncing? I think that the nice thing about single level stores is its simplicity. It exposes persistence as a first order primitive. So applications that want to essentially create their own transactions could do that with Aurora. I'm not sure if that is answering your question, but like basically we do not preclude control from the application to fine tune persistence or create transactions. Mm-hmm. We just make it more explicit, instead of them writing and then f-syncing and then worrying that, like there was a great paper that was recently published by my master, which was showing that applications do not know how to recover from a failed f-sync. Aurora, like instead of kind of having to reason about all these complex APIs, Aurora provides us the persist primitive. And
yes, I fully agree. Obviously, Aurora is going to make it possible for me to do any of the above. It seems my first stop should be, though, if I want simplicity from my application development. Thanks, Emil. Rohan, why would I want to use YNFS in that case if I can just use Aurora?
So I think it depends on the application that you're writing. So if you're trying to, so YNFS tries to basically focus on persistent memory and applications that will be written for persistent memory. And one way in which you can get that is through memory mapping. And the main selling point of INFS is that. So basically, if you want to write your application to maybe perform the best for persistent memory, I think you would want to go with maybe YNFS as a design.
Yeah, in many ways, YNFS is closer to Aurora, and that memory mapped files can kind of provide me with something close to immediate persistence. Of course, I have to still be sure to actually flush things at the right time. So you're a little bit more complex, but I might get maybe a more performance out of it if I know what I'm doing, I imagine.
Yeah, or you use a library underneath for guaranteeing the persistence. Yeah.
Thank you.
You use both. Sorry.
Indeed, you could.
Yeah, you could use both.
And Jing, is there still any use for the POSIX API?
I think it's still going to be useful. I mean, people have blamed it for years, but it's still used a lot. I don't want to argue that why people still use that. It's just a fact. That's the first thing. It's just, and the other part is, I think I'm a little bit into that, like the idea of like make the interface your the guaranteeing of your the correctness guaranteeing of your interface more clear is pretty important. For example, we could in our case, because the library and like the user level thing, we could try to make the atomicity and transactional semantics of the fsync better. Like for example, like this, like the spirit of separating the durability from ordering, that could always easily be incorporated into our design. Since I think I like this direction, like how could give application more flexible control over your correctness guarantee instead of like Aurora is kind of a bit seeking for transparently to do so. I guess there's a little bit like, I mean, I would say I like the idea, but I think there's kind of two directions that, for example, I want to give a several different atomicity transactional guarantee to applications. This is always easy to do with our approach. They're doing a good job for the kernel file system. Like there's a debate for user level file system, and it's going to keep moving. And we have this point that user level thing is easy for application to be more incorporated. I guess this is one sort of the reason to use us. It's like the frequency of the durability is still kind of hard to control, and the state of the application is still a bit hard to manage. I guess I would say like how this two parts go, I think.
Yeah, certainly one thing that can be said for the POSIX API is that it is certainly still very well used, if not perhaps well understood, but it is certainly very well used, right? And so I think one thing that MicroFS provides is a straightforward upgrade path for applications that are already out there that use the API, right? And are going to use the API going forward. And I think you also made a good argument that even the POSIX API, with all of its problems that Emil pointed out, of like applications not really understanding the semantics of fsync, could to some extent perhaps be fixed by simplifying the API a little bit, even within, I would say, the what POSIX standardized. For example, what if we made the file system API completely synchronous, obviating the need for any fsync? Would that get rid of a lot of the problems, Emil, that you describe in your paper?
If we could ensure that we do fully synchronous, very quick updates, then yes. So however, we lose the application persistence part of Aurora, and this is while we have focused on this paper on persistence, because obviously this is the first primitive that Aurora provides. Aurora does a bit more than that, and we have outlined this like in we had a previous OS paper on Aurora where we described that we can use this persistent. We essentially turn whole applications persistent, and we turn them portable between machines and across reboots. And since the whole application state is persistent, we kind of gain the advantage that we do not need to reason about edge cases in the application. Like, even if we have the file system that completely provides these guarantees, we do not know what any data that is not in the file system that has not been written will be lost. And that kind of this still means that we need to have error handling, and we need to worry about communicating with external entities, or maybe we need to worry about things in flight while we are executing. If we have a truly persistent application, we do not need to worry about any crash faults at all. Like, we basically know that we can grab, yeah.
But I think, you know, like for persistent memory, like there are a lot of debugging argument of people don't really understand your persistency model, and it's just the bugs always, when they reboot, it's still a bug. When they reboot, it's still a bug. I mean, cracking is always pretty hard, and they need a lot of techniques to do the debugging techniques, like symbolic execution, just to guard against those bugs. It's just they're all pretty good developer. The applications like PMDK, they still have this kind of thing. I guess there's still some risk there for this kind of thing, I guess. And I guess another point is there's old paper called real file cache. So the idea is simply just when it just crash, we just dump the whole process. Instead of always dump when it crashes, just dump. It's essentially provide kind of similar guarantee, I guess. But how, instead of always write, they can just do the single write instead of write hundreds of times.
Right, there is potentially a trade-off here that as we move away from the kind of very separate API, the separating API of POSIX, where there's a persistent part and the more volatile part, is we're mapping things into memory, or either for files in Rohan's case or for the entire application for Emil's case, that we could open ourselves up to potentially other bugs because the application could overwrite parts of the memory that then will be made persistent by the file system or by the Aurora operating system. That, I believe, was a question that was asked by Andrew Quinn in the Slack. Unfortunately, I have to end it here because we're definitely coming up on time, and I want to give a few minutes to the next session to set up. This was a great panel. Thanks very much to all three of you. Great talks, great answering the questions. Thanks again.
Thank you, Simon, for hosting.
Yeah, thanks, Simon.
I think we need to end the QA session and start our mini panel session. So let's welcome all the authors to panelists. Okay, so yeah, I have prepared some questions. So the first one is that, as we know, the POSIX standard helps a lot in regulating the approach we use file system, right? So it also helps the Aurora to do the checkpoint. So, but at the same time, the POSIX interface sometimes limits the performance of a storage system. So if we can break the POSIX file interface, perhaps a bit by bit, what would you change to further improve the performance of the system? So I think it's similar to the question Aaron Zhang has asked. So maybe let's start from the Emil. Oh, sorry, Emil, you haven't opened your mic.
Can you hear me now?
Yeah, yes.
Awesome. So I would actually not break it for performance. We actually did have a case where the POSIX standard was preventing us from checkpointing properly. And that was because the POSIX standard, there is a case where a process can open a file, can create a file, open a file, and then unlink it. And then it has an open file descriptor to a file that does not belong to the VFS. And that means that it is not accessible. That POSIX allows file systems on a restart to clean up this file. And that meant that if we didn't keep this file alive somehow, we would lose the data, we would not be able to restore. This was one of the reasons why we actually created the file system for Aurora that kind of handles these kinds of edge cases. Also, obviously, like with Aurora, the POSIX standard, like the fsync call, which I believe is in the standard, was causing trouble because Aurora only provides consistency at specific points in time, that is every checkpoint. And at the rest of the time, it uses external synchrony to prevent any inconsistent states from being externalized. So basically, POSIX did help that it was regular, and we did work with it up to a point, but then we did need to overload it on in some regards.
Oh, thank you. So go ahead.
Yeah, so this is a nice, interesting question. My answer to this is that I will speak in terms of modern storage and memory devices. Like, so you have more byte addressable storage like persistent memory and stuff, right? Which has basically a similar interface to DRAM. And that is where I think POSIX comes in the way, where you have to have a separate representation from your memory representation. And in order to convert between these representations in terms of file, to change everything in terms of files, like serialization, deserialization and stuff, I think that causes more overheads. If you could like have more closer representation of your data, or like in memory, especially for byte addressable media, I think that would be great in having as an interface for storage. That would also simplify applications, I feel.
Okay, so Jing, do you have something to add since you have answered a similar question?
I would say we probably have a lot of research work for this. I mean, something like perhaps, I think I agree much with Emmy's point of like the correctness is very hard. So for that, we could do like a optional transactional like interface for correctness. This is kind of like, how should we, like we blame that the interface is not well specified. How could make sure the new interface state the correctness explicitly? This is one thing. And another thing is, like the reality is the file system usage case, like the data flow of application. Like I think Facebook last year have a paper of how their like RocksDB is used, and they have very different access pattern for upper layer applications. Therefore, how should this kind of access patterns somehow be represented in this kind of interface? I guess this is kind of the reason that we want the file system to be able to develop files. Like actually the cost for us to enter system call is just to change the library. I think this holds for Rohan's work and my work. It's like we really want the application to take advantage of the device much more easier than before, and we hope this become easier. And yeah.
Okay, thank you. So June Park, I saw you posted but has reviewed some questions on the Slack channel. So do you need to answer the questions here? June Park, okay.
Oh yeah, I actually I posted it before, but I don't know why it just uploaded now. It was like an old question. I also wanted to ask about like what kind of futuristic API would be instead of like POSIX, like traditional read or open, whatever. Yeah, anyways, you guys answered already. Thank you.
Okay, so do you have something to add? If there's nothing to add, we can move to the next question. So I noticed a very interesting fact about our session. We have 3 papers in our session, and YFS is a kernel space file system, and UFS is a file system semi-microkernel in user space. And in Aurora, the applications don't even know that there's a file system. So, and we also know that there are many paper on the file system on the smart NIC or smart device or smart storage, such as the LineFS in the last session. So what will the file system or the storage system be like in the future? And how do you think?
I think that in general, it makes sense that I think there's a trend in general with we saw that with other talks in this conference, like for example, Ghost, that was scheduling to user space, and I feel like it makes a lot of sense to have this kind of very this kind of balance between doing between having policy only in user space and being able to very quickly update things from there, I guess, and this also applies to file systems, and doing kind of I wouldn't describe it as pass-through, but basically putting less abstractions between the device itself and the application. I think this is the way to go with file systems. And I think we see that with, for example, persistent memory makes sense to be exposed pretty much directly to the application and have a very lightweight abstraction on top instead of having a full-fledged. Yeah, like we see that file systems that use persistent memory are more lightweight than traditional file systems, basically. So in general, my point is lighter and more, everything is lighter and more configurable. I don't know how to explain it more concretely.
Flexible.
Yeah.
I think I agree completely with Emil. I personally have also worked on user space file system in the past. And I believe that that is actually an interesting future work also for YNFS. It is not I mean, we were not too tied on whether it should be in the kernel or not, because we had to make allocation decisions. We put it in the kernel. But I think removing the operating system overhead in general, I think seems to be a trend going for file system designs. And I believe that in the future, there will be more user space, more focus going on user space designs rather than making the kernel even more beefy.
Okay, thank you. And Jing, do you have something to add?
I think one thing could be, let's say I would imagine let's have Aurora YFS and microFS just runs in one single computer, and every application can choose what they want. I guess this is a kind of one fun thing to do. I guess the point is, for example, one code can run one file system, another code can run another file system. Like your devices, like for example, your PM is it's kind of orthogonal to how you understand your layout. It's kind of how we could really enable this kind of scheme that share in another level and try to provide different choices in one application. It's kind of something to think about, because one trend is just really the multi-core case, and we have CPU. Sometimes the storage is just not that fast, and we can see the trend that you just run two file system together. Possible, I guess that's the point. Yeah, and I think like correctness, like we should probably have better handling of the error code. I don't know how you handle the malloc filling, by the way. Because my colleague has a very good paper for fsync filling, so I'm not sure how you handle the malloc filling. So kind of like that.
Okay, so to the time limit, we have to end the session now. And if the audience or the authors have more questions, we can still discuss in our Slack channel. So thank you very much for all the audience and authors, and wish you all have enjoyed the rest of the conference.
Yeah, thank you for hosting.
Thank you.
Thank you.
Bye.